Hello there. Okay, so hello there. Good morning, good afternoon, or good night, or good evening. My name is Cristiano Valerian Pradipta Tarigan, 23, K4, triple O1, up in this bitch. Okay, so this is going to be the submission of the file project for the Big Data Analytics class. And the goal and the purpose of this project is so that we can implement AI algorithms, whether it be collaborative filtering, whether it be classification or other sort of AI algorithms into an actual study case. In my study case, I am going to be using a really large data set, which is a stored data set, and implement clustering using the power of the k-means method in order to find some analysis and to see whether or not the k-means can be used to categorize shopping goers.
Enrique!
Okay, so first things first, before I get into the actual, whether it be data set, the analysis, or the product, I would like for me to first clear up a couple of things, clear up a couple of definitions before we get into this video. So there are three terminologies that I'm going to be using. Not we, there's no we, it's just me, I'm alone. It will be RFM. The second one would be k-means itself. And then we have the elbow method. Elbow these nuts in your mouth. So in order for me to explain this, I'm going to reference my favorite content creator, my favorite Twitch streamer, and I'm basically inspired my head out of that man. That is, of course, Pirate Software. Okay. We have pain. So if you don't know who Pirate Software is, he is a YouTuber who does this stuff. You know what I mean? He likes to do stuff. I hate that man. But anyways, let's get into explaining this. Number one. Jesus Christ, look at me go. Oh my God, look at me go. Oh my God. Oh my God. RFM. So, RFM is an acronym and it stands for recency. Great. Frequency. Oh my God. And monetary. So, recency, frequency, and monetary. RFM is basically a term or an acronym used in analysis of shopgoers or customers of certain supermarkets in order for them to categorize based on the recency, frequency, and monetary. So, what is recency? Recency basically means the time interval, how frequent the shopgoers actually go to buy something, whether it be in the range of days, whether it be in the range of months. That's basically what it means. Now, frequency is how many things they buy in a single shopping spree or a single shopping session. Could be a little, could be a lot, whatever. And then M, monetary, is of course the price. They buy expensive things or non-expensive things. Let's say the shopper, right, goes to a store. This is Pirate Software. Oh my God. They go to a supermarket, right? And let's say that they buy not a lot of things, but they buy expensive things. What does that tell us? What that tells us is this person buys something that's not perishable. So things like it can last a long time. For example, I don't know, maybe toilet paper, soaps, shampoos, those kinds of things that you buy only maybe once a month, but those are pretty expensive. Those are expensive that you only buy once a month and you don't buy a lot of them. So that's the example of analysis you can use in RFM. The second one is, I'm gonna go k-means first, yeah? what is k-means? K-means is an algorithm that I'm going to be using as a form of clustering in order for me to be able to cluster the data that we are going to have today. So basically, k-means is a method in which you can use to cluster stuff based on random points and how they sort of correlate with the data points in the dataset. I'm going to be talking about it much more later. The third one is going to be elbow method. I'm not going to write this down. I'm not going to do it. So elbow method is basically the prerequisite of the k-means. The elbow method is a method used to find how many groupings is optimal for a set dataset. So using some math thingamajigs, math magic, you can be able to find how many clusters can actually be found in this data. That's what elbow method is. Yep, so that's the 3 things that are going to be the main focus of this video. Now let's get into that data set, bruh. 2, 1. Online retail to UTI. Okay, it's not UTI. I'm just kidding. It's UCI. Yeah, so this is the data I'm going to be using for this k-means practice. And this is the content, not really important. Not really too important. But the most important thing is because we are doing big data, this particular data set contains 1 million rows. Jesus Christ, who has the time to collect all this? I don't know. That guy must be jobless or job full in order for them to collect 1 million rows of... God knows how many it is. Okay, so this is the data set itself. It has 8 columns. Let's go to the header here. Okay, so we got invoice, stock code, description, quantity, invoice date, price, customer ID, and count. And country. Jesus. So I guess the big question is, who is this implementation for? This implementation is very, it can be very well used or suited to people who work in managerial positions in a retail store. In this case, an online retail store. They can, whether they need to categorize some people, whether they need what kind of niches that they would be able to emphasize into their product or their career as businessmen or businesswomen. This is the perfect study case for this video.
Adrian.
Okay, let's get to the juicy stuff. Okay, let's get to the juicy stuff, which is the code, the analysis, the k-means. You know what's up, man. I was gonna brush over this. I know that you probably are bored to do this. I mean, this is I had a brain fart, sorry. This is not too important, because the important shit is, of course, the implementation. But of course, let's look at the data first in its raw form.
I'm gonna go.
Let's see here. I cannot touch this, but I swear to God, dude. I cannot even. This data set is so gargantuan. My Google Sheets is having some problem with it. I don't like that. I like that. Okay, so this is online retail 2, UCI. Just open it in my Google Sheets here. And so the main point here is to the implementation itself. Let's get into k-means. Let's get into the meat and potatoes of k-means. So what is k-means in practice? Because you have multiple data points, you can make it into a plot. So let's say this 0, 10, 20, whatever it is, and you have the x and the y. So let's put in the data. So 8, I don't know, 12, 24, blah blah, and it's according to x-axis, whatever. And as you can see, when you make these data points, they will scatter onto different things, right? They'll scatter into different places. So what k-means does is it will make one center. That's kind of what it's called. A center. Boom. And then it will find the things that are closest to the center. Like that. And then that will save it as, and they'll save not only the center, the point at the center, but also the distance between the data points and the center. And that, because it's attracting multiple data points, that's what we call a cluster. So let's first see what the elbow method is. So as I said earlier, the elbow method is to find what K is. The K in k-means is basically how many clusters are optimal for this type of data. So, as I said earlier, this is how you do k-means. The elbow method is when you do this k-means multiple times, and then you'll find a WCSS. WCSS is basically the tightest clusters at the different points. And the different points with the tightest clusters, or the points where the data points are the closest to the center, is an optimal data center. And then how many data centers there are that are super tight is what you'll find in the elbow method. I'm using K3. Maybe 3 or 4. I might actually have to run this again. But let's just say 3. Let's just use 3 for now, eh? So, so this is 3 clusters. So we have, as you can see, 3 with color coding. And you have the customer segments on the left here, recency versus frequency, and on the right we have frequency versus monetary. As you can see, it's divided into 3 parts like that. Like for example, let's just describe what sort of person is this green one right here. So recency wise, they go pretty frequently, and then frequency wise, they're pretty high, which means they shop very frequently and they buy a lot of things. Now the question is, what the hell is going on with this visualization? Why are there clusters on top of each other? That is a very good question. So RFM, as I said earlier, let me just clean this up right here. RFM, RFM is 3 letters. It's 3 letters. Duh. RFM is 3 letters: recency, frequency, monetary. And for this analysis to work, you would actually have to use 3 of them. Not only 2 of them, but 3 of them. That's why the visualization was actually kind of messed up, because we're trying to interpret 3D categorization through a 2D lens, which is just wrong. And so what I did, wrote a bunch of code, and then boom, you have the super clean 3D plot. And as you can see, you can categorize people based on these 3D plots. Oh, Jesus. Okay. So you have x-axis recency, the y is monetary, and z is the frequency. And as you can see, it looks a tiny bit better. This makes a lot of sense. Let's for example, look at the green one. On the green one, the frequency, they buy a lot of things, right? They buy a lot of things. Let's look at the recency, but they don't go there a lot. But when it comes to the monetary, they're kind of all over the place, but they're pretty high. And so, as you can see, this is a really good categorization, not only because it's logical, but also makes sense in sort of, I guess, today's society. Yeah. You got the people who are super rich, they don't go to the shop a lot, and so they don't buy a lot of things, but they buy things that are super expensive. And then you got the yellow one, which is, I guess, a bit more mixed. They go to the shop a lot, but they don't buy a lot of things, and they don't buy a lot of things that are expensive. And then you got the purple one right here. They don't really go there a lot, I guess. They don't buy a lot of things, and they don't really buy things that are too expensive. So those are the 3 kinds of shoppers. You got the people who are super rich, they buy super expensive things. You got your average shopper, and then you got a person who's just sometimes go to the shop for something. Now let's get into the next juicy stuff. accuracy. So accuracy of k-means is very well documented, and it's very much needed if you want to, whether or not you want to use the analysis that we have done in this image. So I'm gonna maximize it. Silhouette score. So I'm basically using silhouette score and Davies-Bouldin index in order to realize what accuracy my k-means algorithm is. Okay. Okay. This is the plot, but the important thing is the numbers. I've also put descriptions on it. Silhouette score range from -1 to 1, higher is better, and I got a 0.6. I mean, it's pretty good, I guess. And then the next one's the Davis-Bouldin index, lower is better, and I got 0.5510. So that's trying to say that this is a pretty good k-means implementation. So I guess I can say that this is pretty much a success. So what did we learn from here? Generally, we don't know. I'm just kidding. So what we learned from here is using the power of AI. We are able to use it on day-to-day circumstances, even something as simple as categorization for shopping goers, or for customers in your area, or in your shop, or online store, whatever it is. And with this, I hope that this type of technology can be used more in the future. This is very good for recommendations, or again, if you want to find your niche, what you can sell, whatever. So that is the conclusion for today's video. Thank you so much for watching, and peace.